Hey everyone, my name is Andre Azari, and today I'm going to talk about the lecture I attended on October 21st entitled Superposition, Entanglement, and Raising Schrodinger's Cat by David J. Wineland. As most of you know, Wineland won the Nobel Prize for Physics for the research he did on the topics he covered in this lecture. Um, According to the Nobel citation, the official citation, Wineland won the award for his groundbreaking experimental methods that enabled measuring and manipulation of individual quantum systems. Um, According to the ideas of quantum superposition and entanglement, this was previously thought to be impossible, which Wineland touches on at the beginning of the lecture. Like I said, in order to introduce the topic of superposition and entanglement, Wineland uh, gives the audience a quick overview of the Schrödinger cat experiment. I wasn't too familiar with the intricacies, I guess, of the experiment. So here's a quick, I guess, to set up the experiment for you in case you didn't know about it. Basically, it consists of a cat, a flask of poison, and a radioactive source, all of which are placed inside of a sealed box. Inside the box, there's an internal monitor which detects radioactivity, and upon detecting radioactivity, which in this case would be a single atom decaying, the flask will shatter and release poison that will kill the cat. Um, the Copenhagen interpretation of quantum mechanics implies that after a while, the cat is simultaneously alive and dead. Um, Yet, when one looks into the box, one will only see the cat is either alive or dead, not both. This poses the question of when exactly quantum superposition ends and reality collapses into one possibility or the other. So, to further explain, I guess, the ideas of superposition and entanglement, Wineland gives his own example of a marble inside of a bowl. The marble can only exist in two possible states, so it can either be on the right side of the bowl or the left side of the bowl. Um, However, Wineland explains that according to the idea of superposition, it says that the marble actually exists in two states simultaneously. Not, uh, it isn't until we try to measure the location of the of the marble that we see that it can only be read in one state. Um, so this leads to Weidmann's discussion of quantum entanglement. Wineland says that, um, again, using the marble and the bowl example, he describes entanglement as the idea that the state of the marble can't be described unless it references the other state, the other possible state. So um, after this, Wineland goes into a lot of the detail and like inspiration of how he, I guess, started this research, like um, through his days at Harvard, um, and subsequent postdoc work. Um, he he obviously goes into a lot of great detail of his research, which a lot of it was way over my head. But he centered specifically on his method of trapping the ions and using photons to study them, so that he could actually study them. Um, he went on to discuss how this research has enabled him to build incredibly precise clocks, and he discussed that, kind of summed up that these discoveries um, and other similar research will result in the building of computers that are much faster and more powerful than they are today, otherwise known as quantum computing. Um, as a whole, though, the lecture was really interesting. I learned quite a bit about quantum computing specifically. Um, I never actually even heard of it. So the idea that the thought that these groundbreaking, I guess, developments are just on the horizon is pretty cool. So that's all I have. Um, Hopefully, there's a lot of YouTube videos and things online that Weidmann's Wineland's done in the past. So I really encourage people to go and check those out if you didn't get a chance to check out the lecture. But thanks again. Have a good one.